Before talking about topology, let's set our foundation for mathematics. As of now, all we need is well-defined objects. Well-defined, as name suggests, it must be well-defined by someone, but by whom? We need a guy who is purely based on logic. He must be independent of people, time, everything. If he says something is true, then that must be true from the beginning of universe to the end. We call him truth indicator. Let's see some examples. Let me introduce an object, 1, and another 1, and a binary operation for these two. This 2 will produce another object, 2. These 1s and 2s are not we're using in real life. I just created them and named them this way. You can name them A and B also. What really matters here is what I defined here. It has nothing to do with real numbers 1, 2. Let's create one more set like this. Also, I set this binary operation obey commutative property, like both 1 plus 2 and 2 plus 1 are same. It also obey associative property, because for a binary operation we can precede only 2 objects. If we have more than 2, we can proceed for any 2 and go on with it. Now, let's find out what would be 2 plus 3 by using commutative and associative of our binary operation, and of course the things we defined before. Replace 2 and 3 by 1 plus 1 and 1 plus 2 respectively, and go on. Finally, we will get 2 plus 3 equals 2. Add this to our collection. Just like this, we can find 2 more. Now, if I say 2 plus 2 is 3, then our truth indicator will say false. Another example is by using relation between objects. Suppose x is related to y, and y is related to z, then x is also related to z. This kind of relations are called transitive. Also, if x is related to y, then y can't be related to x. I named this kind of relation as hello. Some relations satisfy both of this condition, for example, lesser than relation in real numbers. Relations which satisfy both transitive and hello, I call them meow relation. Let me create a relation on objects 1, 2, 3. 1 is related to 2, 2 is related to 3, and 3 is related to 1. I wish the relation defined here is meow relation. Let's find what others also related. By transitivity 1 is related to 3. But by hello, this is false. So the knowledge we get here is, relations we defined here are good. But this is not well defined for meow relation. These are called not well defined. Now we have an idea of well-defined objects and not well-defined objects. We call the collection of well-defined objects as set. Collection will be placed between 2 curly brackets. We can have the collection as 1, 2, 3, or a B, C, D, or even may have some meow relation. Different relations can be differentiated with different subscripts. Even more specifically, we can have a relation previously we defined on 1, 2, 3. Oh no, someone is triggered. Truth indicator is coming. He spotted a non-well-defined object. Because this set is specifically defined for meow relations, this relation is not well defined to enter this set. Now we have basic foundation on set theory. Let's see some basic set, real numbers. Real numbers are denoted by this symbol. It has uncountable numbers, so it is impossible to represent all numbers within a curly bracket, so we can't see what exactly are these. But in set theory, what information we get through a set of real numbers? The set only tells us the information, whether an object exists in this set or not. For example, if I say 1 belongs to this set, our truth indicator will say, true. If I say it has an element which is squared and added to 1 will give 0, then our truth indicator will say false, because x squared plus 1 has no real root. Elements of set possess a common property. If you want to check whether an element belongs to a set or not, you have to check whether that element has that common property. Common property doesn't need to be explicit. A set contains a real number, a function from complex number to real, a meow relation. What are those common properties these elements possess? The common property is these are coexists in this set. We may need these elements together for some reason. Even without a reason you can collect like this. In particular, sets are the reasons for a common property. Remember, we defined a relation on 1, 2, 3, and wish to see whether it is a meow relation or not. It means there is a set containing all meow relations. We are searching this relation on this set, but our truth indicator doesn't let that relation in. This is what I mean common property. We are defining sets to induce common property among elements. For more clarity, what do you think about the starting point for math? You may think it's numbers. Initially humans created numbers to count. So counting must be the starting point for math. But before counting you must know what do you want to count. The things you want count as a common property. We count something by watching them or hearing, or any information we get from sensory thing in our body. But we get so many information from these sensory things. Truth indicator in ourself will choose which one to count and which one to not. So sets are the most basic thing we are using in our real life, even without we knowing it. In math, we are defining here rigorously. Study of things happening among elements within themselves is called algebra. Topology is study of how those elements placed. How those elements placed is useful to view them as an object. But why they define topology this way? You get the answer in next video.
Wait up! 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 Wait up!